This video is going to be about the Live Stacker, which is a project I've been working on for a little while. I've just merged the first version of it into Git in KStars. So for those of you that are able to take code from Bleeding Edge and build it yourself, then you're more than welcome to pull it and have a go yourselves. For those of you that can't do that, it should be in the next release, so you can take a look then. Obviously, as new software, I'd be very interested in any feedback. Still got a few things I can add in that are on the list that need to be done, but obviously very interested in any user feedback, so please come back with any comments. So let's get into it. So I've just run up KStars here. It's not a live environment, it's just a development environment, but I should be able to demonstrate everything here. So there's a new option called live stacking. In order to get this, you will need a build with the OpenCV module, WCS module, and CFIPS.io module. So they will be standard on a standard build, but if you're customizing your build for whatever reason, you will need those modules. If you build without those modules, this option will not be visible and you won't be able to run it. So if I click it, I get this window, which is a FitsViewer window. So for those of you that are familiar with KStars, I'm sure this will be recognizable. It's opened on the live stacking tab, which is a new tab. What I should say is if you start FitsViewer from a way other than live stacker, so for instance you just said open images, you won't have access to the live stacking tab. So the only way you can get access to the live stacking functionality is to start from here, from live stacking. So this is the basic tab. It sits in FitsViewer. I'll go through the benefits of having it in FitsViewer as opposed to having it as standalone a little bit later. But once in FitsViewer, you obviously have access to a lot of the functionality that exists for viewing other Fits images, so that's why it's there. I suppose I should also say that at the moment the live stacker only operates on Fits files, so any files that it uses must be Fits. It won't operate on them if they're not. Obviously that could be changed in the future, but for now that's how it is. So I'll just kick it off, and I'll talk around it as it's stacking. So this is just a stack, a directory of subs that I have that it's on M3, and these happen to be green, but could be anything obviously. You select the directory you want to watch, which is this stack directory, and then you just hit start, and off it'll go, do its thing. So it's showing the results over here, the image, and over here you can see this number here is the number of process subs, and it's sort of ticked up. So it's processed 40 subs, 0 failed, and there are a total of 40 in the directory. So it's produced that. So you can use the FitsViewer buttons to zoom around. You can do all the things that you would expect to be able to do within the FitsViewer. So I can rotate the image if I wanted. I can mirror it if I particularly wanted to do that. I can show various pixel grid lines, and these are the equatorial grid lines if I wanted to do that. I could look at any overexposed stars. I think that one's overexposed, can barely see it on on here. And in terms of, I can look at the histogram, for example, stuff like that. So you get all of the normal sort of functionality that you would within FitsViewer that is operating on the stacked image. So just down here, I can look at just the mid-tones, the light point, or go over here and do the dark point, which is all fine. High has just put in a couple of features down here which are coming in the next release. So he's put in some presets that you can, I think there's 7 of them that you can cycle through, decide which one you like the best. Anyway, these functions are obviously standard functions within FitsViewer that you can use on any live stack to adjust what's on display, etc. So that's a basic use case. The other use case would be where you're starting a session, you haven't got any images, and they're going to come in over the course of the evening. So I can simulate that. So if I go back to like an empty M3 directory and hit start, so you always have to hit start once you've changed the directory, or for that matter any of these parameters up to this point here. So if you change any of the stacking methods or whatever, just hit start and it will basically go again from whatever happens to be in the directory at the time. So there's nothing in there, so it's displayed this sort of null image. Down here in File Manager, this is looking at the directory I'm watching, and there's nothing in it. So I can simulate a sub coming in. The way Live Stacker works is to watch the directory that you put in here as the stack directory, and then when a new file appears, I'll put one in. It will wake up, realise there's something for it to do, and it will stack. Now this is only one image, so it's just the image, there's nothing to stack. But if I add another one, it'll wake up and it will stack the second one against the first one. If I had a third one, it'll run again. Now I can see up here, it's processed 3 images, failed 0, and there are 3 images in the directory. So you can keep tabs on what it's doing, whilst it's running. So obviously I could keep doing this, but I think you probably get the idea. And obviously this dovetails quite nicely with the existing blinking functionality. So if you wanted to blink the files that you're stacking, you can just open up a blink, and it'll just add a tab there, and then I can on the right keystroke, I can go backwards and forwards with blink and look at those. So that works quite nicely. So that's the basic functionality. What I'll do now is just talk very briefly through the various options. I'm not going to spend a lot of time on each of them, but I will, I think, just talk through each one. Let's pick up another stack so there's a bit more eye candy to look at. So this is the Crescent Nebula. It's something I've been imaging for a while. I'll just set that up to there, and we'll come back to why I'm doing that. So whilst that goes off and does its thing, we can just talk about the next section. So the start button obviously just fires up and starts watching a directory when you when you select a new one, so it'll stack whatever happens to be in that directory, and then it will continue to watch that directory for new data coming in. Obviously I just mentioned the sort of the processed fail and total, so you can keep an eye on how many subs it's processed. There's a little bit of stats on signal to noise for each of the subs, and then signal to noise for the final image. This little widget here is useful for keeping an eye on how much memory is being used by KStars. So it's not specific to the live stacker, it's the whole process. But obviously, and we'll come to why, but a stacking process can gobble up all your memory, which you don't want to happen. So you want to be keeping this little widget in the green. It'll go to amber and then to red if you start getting towards the end of your memory, but that's not a good place to be. And I'll go through how you can minimize your memory usage in a moment or two. This button here will save your settings, so what you can do is you can pick your favorite settings, hit that, and then every time you fire up a FitsViewer, it will, or a live stacker rather, it'll default the live stacking options to whatever was in the last save setting. So they're not persisted every time you change them, they're persisted only when you hit the save settings. The reason for that is you could fire up multiple live stackers, and I'll do a little bit of, I'll demo that towards the end. And obviously if you do that, you don't want values to be overwriting each other. So basically what will happen is every time you fire up a FitsViewer in live stacking mode, it will default to whatever you had set as your save settings most recently. Okay, the next section is calibration. So you do have the option to put in some calibration frames. So why don't I do that? So I happen to have got a master dark and a master flat. If you do that, it'll do what you would expect. It'll just calibrate each of the subs with these two masters. What you will have to do is get yourself a master in a Fits format. So for example, if you're using PixInsight, you can save them off in Fits format. You probably will save them in the internal Fits, the internal PixInsight format, which is what I do. So you'll just have to save an extra copy in Fits and then get it back onto your imaging machine, and then you can use it. You don't have to use them, but obviously they'll give you a slightly more pleasant image if you do use them. You can here select a master sub to align to, so I could pick one of these if I wanted to, or if I leave it blank, it will just use the first one it comes to, so that's up to you. This method at the moment is just plate solve. It might change in future, but you can't change it for now. Down here, I'll just very briefly go through these stacking options. I will come back to this in memory subs when I talk about how you can minimize your memory usage in a little bit, because it's slightly complicated. Next option, downscale. So you can downscale images. So if I put none in there, basically it'll take the scaling of your sensor. If I put 2x2, it would in effect bin that at 2x2, and similarly there'd be a bin 3 and a bin 4 if you wanted to use that. So basically what that's doing is downscaling the amount of data it's processing. So if we take 4x4, what it's doing is it's going through the image, and for each 4x4 pixels, for each blob of 16 pixels, it will average the 16 values, and save 1. So in effect, you've got rid of 15/16 of your data. So it's going to be processing considerably less and therefore will run a lot faster. So this is something to change if you are struggling for speed because the machine you're running it on is slow. Also, if you're using color, color is a lot slower than mono. So obviously with a color image you've got 3 pixel values for each actual pixel. So you've got red, green and blue. So you've got 3 times the data, but also there's more processing that goes on between formats. So the way Fits stores the images, it stores it in a way that you need to debayer. So there's a debayer algorithm that needs to go through and convert the proprietary Fits information into something that KStars can do something with. So there's a lot of extra work that goes on with a color image, therefore it will take a lot longer to process. So I suspect if you're on color images, you need to be looking towards the 4x4 downscale side. Anyway, that will be something for you to experiment with. Pixel rejection, the fastest mode is going to be none because it's doing the least work. You can do Sigma clipping, or you can, I put in a form of Windsorized Sigma clipping, so you could have a play with those. These are going to be going through on a pixel by pixel basis, manipulating the data, so they will be a lot slower. So if speed is your thing, leave that at none. Frame weighting, again, equal frame weighting, very simple. Every frame has a weight of 1, they're just added together. You could weight them by HFR, so the smaller the HFR, the higher the weight. Should theoretically be more accurate. Or number of stars, so if for instance you're imaging and some high cloud goes over and your image sort of disappears, you'll probably be seeing less stars, and therefore that if you had the num stars as your frame weight, then those images with cloud would probably have a much smaller weighting than those without. So anyway, you can play around with those, but just to say the simplest and fastest is going to be, leave that at equal. If you had selected Sigma clipping, then you can set the high and low sigmas, and if you had selected Windsorized, you can, in addition to the high and low sigmas, set a Windsorization cutoff. So that's that. So there, I'll come back to the post-processing at the end, but they're your basic options. So you can play around and you can run this. So we'll just watch as I'm running this. You see the memory usage going up as it's reading more frames in. You'll see it drop now, and I'll come to that. At least I hope you'll see it drop. Okay, there we go. It's dropped down. So here's my Crescent Nebula. It's calibrated by a flat and a dark, so my usual vignetting is disappeared very nicely, so that's good. It's still going, it's coming up to sort of 33, which is the total number of subs in that directory at this point. So that's that. So basically, why was the memory increasing, decreasing, increasing, decreasing? So the reason for that is that it's predominantly controlled by these two controls here, so the in-memory subs and downscale. So with no downscaling, I'm using more memory than I would do if I downscaled the images, because there's just less data to hold. In-memory subs basically gives a high watermark for how many subs I will hold in memory at any one time. So what it's done is when I hit the start button, it read the first 10 subs into memory. It then processed them and displayed the result. It then released the memory for those 10 subs, having persisted intermediate results for that initial stack of 10, and then as it read the next 10, it used the intermediate results it had persisted along with the new set of 10 subs to calculate the next stack, did it again for the next 10, and then for the next 3. So at any one point in time, I'm going to have no more than 10 subs in memory. So the lower I set that, the less memory usage I'm going to be basically using. So if you need to control the amount of memory, because this widget is going amber or even worse red, then you probably want to look to drop this number down. If you're using a pixel rejection method of none, there won't be any downside to putting that to a lower number, but it will basically refresh the stack each time it reaches whatever number you put in here. So if you wanted to stack 100 frames and you set this to 2, it's going to refresh the image 50 times, so that's going to take a bit longer than if you had this set to a bigger number. But if you have it set to a bigger number, you may run out of memory before it completes the stack, so you're going to have to play with that. So that's that's basic tour of the stacking parameters. One thing I didn't show when I was going through the other FitsViewer standard things you can do is I hadn't shown my favourite option, which is to look at the very exciting objects that you can find in the Simbad database. So the stacked image is already plate solved, so you don't need to bother plate solving it. So I could see, well, what is that thing there, and I zoom in, hopefully we can see it. So there's a couple of interesting objects there. Do that again. So these are the objects that you can basically do some investigation on. The other thing you can do is just use it's a little tricky to do, but if you use the zoom in, you can go and zoom in and have a look at stuff that's in your image. Anyway, that's all existing functionality, but it is available. The only thing I would say is you do need to be on a downscale of none for this to work at the moment. I do need to fix that. If you are downscaling, it's not downscaling the image properly from an object perspective, but I'll fix that. So that's sort of the functionality, I think. So how would you go about using this? I think is a good topic. So you have a few options. You can basically just use one of these. You can watch a directory, and if you change filters or change object, you can basically just select whatever your current directory is that your imaging is creating subs in, and you can just see what's going on currently. You can, if you want, run multiple FitsViewers in live stacking mode, and you can basically stack stuff up from different directories. So if you wanted to do that, and that might be useful, for instance, if you were imaging multiple targets and you wanted to have them all on the screen at the same time, for instance, or if you're doing multiple filters on the same target, you without swapping backwards and forwards, you could you could run multiple live stackers to look at each of the filters. So if you wanted to do that, all you need to do is fire up another live stacker like this. So let's see if I go back to my M3 again. 4x4, it'll run a bit quicker, and just run that. So I've still got my present nebula, and if there were to be any subs coming in, that would obviously just add to the current stack. And then if I was now imaging my M3 and I've got subs coming in, then they're going to be updated. So this is one way of doing it. You've basically got separate windows, and you can create as many of these as you have memory for, and you can keep stacking stuff up, or you could run, so I'm sure you can imagine what to do. The other way to do it is if you look at if you look at the fits option, there's a bunch of stuff which is all pre-existing over here in the fits configuration panel. Now if you have this single window capture off, then each time you launch a fit stacker, it'll launch a new window for you. If you put that on, then when you go to live stacking, and let's just stack these up so you can see. Now if I go over here and launch another one, what you'll see is we've actually got two tabs in one fit stacker. So if I now, let's pick something else. Let's pick this was the water bug galaxy. So here's my M3 in this tab, and then over here when it gets there, okay, it's quite faint, so it's quite a faint galaxy, this one, so it's not too clever, but anyway, it's going to chug through. I think you get the idea. It's going to chug through and update that. So you got kind of two modes you can run the live stacker in if you wanted to run multiple versions at any one time. Okay, so just one other little trick. If you are struggling for speed with color images, one thing you could do is you could take this 3D cube off. Now to some degree this is a little bit it's not the best option, but I'll just tell you about it in case you're not aware of it. Basically, color fits images are debayered into what KStars calls this 3D cube. So if you turn that off and you try and load a color image, it'll display it as black and white. Now, I guess if you've paid for a color camera, displaying it in black and white may not be what you want to do, but it would mean that you would be able to load the images probably 4 or 5 times faster. But that's kind of the option of last resort, I would suggest. The other options, you will need to auto WCS, so most people would have that set on, and if you are using color, you probably want to auto debayer as well, so I would definitely keep those on. These other options, I other than the single window capture, I would keep the rest on, but if you have a specific need for FitsViewer to operate in a slightly different way, then you may want to do something different. But anyway, it'd be worth just checking these out before you start using it, or if it's not behaving as I'm demonstrating it in this video, one place to look would be how you've got these values set. The other thing probably worth saying if you're going to start using this is it uses plate solving for alignment. So if it can't plate solve an image, it will reject it, and you'd see it here as one of the failed subs. If you do start getting that, what I would do is I would go to the plate solving and I would see how you've got that configured. So the way Live Stacker works is it takes your default settings from this plate solving tab. So whatever set profile you have defined is what it's going to use as its default. It does tweak some of the settings, but not that many. So if you choose a set profile that really doesn't work with your camera or with your imaging setup, then Live Stacker is not going to work very well for you. So if you are getting a load of failures, look in the log, it'll probably tell you that it wasn't able to plate solve it. Now in that scenario, what you probably want to do is come over to the plate solving tab, bring up a sub, and try and plate solve it. Now the usual reasons that plate solving doesn't work is there aren't any stars, or the set profile is such that it can't detect any stars, or at least not enough stars. So the defaults that get provided with KStars work for most people most of the time, but they don't work for everyone. So you might need to play around with this a little bit. There aren't too many things to do other than have a look at whatever the default parameters are. You could obviously change them if you wanted to. As I say, for most people most of the time the defaults do work, but one of the prerequisites for having Live Stacker working is that it can plate solve. So as I say, if you start having problems, this will be a place to have a look. Other than that, my suggestion for getting started on this would be, once you've got the software loaded on your imaging PC or your imaging machine, what I would do is I would let it run probably in the daylight on some subs that you've recently taken, and I would make sure in daylight everything is working fine, you can plate solve fine, the settings are as you want. I would keep an eye on this memory monitor, and as you load up more subs, etc., I would try and keep this in the green, and I would use these tools of, the in-memory sub and the downscale to reduce the memory usage such that it remains in the green. And when you've got things set up as you would like, then you can probably run this with your imaging rig. Probably just spend 2 minutes talking about this last section down at the bottom of the tab, which is post-processing. So these are just a couple of tools I've thrown in. Once you have an image like this, what you can do, I suppose I should start by saying I would turn all of these tools off at the start. You can set them to other values if you want, but what I would do is I would save the settings with the three amounts, the deconvolution amount, the denoise amount, the sharpen amount, all set to 0. That will basically turn these tools off whilst you're building a stack. They can be quite compute intensive when they run, so I would just be a little bit careful about, running them too much. But there's no reason why you can't, but it will just slow everything down. So I've got this set up such that the stack is just being displayed, and what we're seeing here is the raw stack. It's been, it's not been processed. I mean, other than, it's been stretched by, this widget at the bottom, but other than that, it's not being sort of processed. So there are three little tools that you can play around with. They're very basic forms of much more sophisticated tools that you can find in other post-processing software, like PixInsight. They're not in any way as good, but you might find some use for them. The first is deconvolution. So this will do a very, very basic one-pass deconvolution. It's called the Wiener deconvolution method. Probably not as good as Lucy Richardson, absolutely not as good as Blur Exterminator, but you might get something out of it. What you have to do is put some sort of sigma in here that is going to operate on your setup. It will be changed by any downscaling you have going on, so you might need to adjust that. And then for the deconvolution, all you do is you put in a percentage, or a fractional amount between 0 and 1. So 0 is nothing. 1 would be take 100% of the deconvoluted value and display that. As you can see, there's lots of ringing artifacts here. Or maybe if I zoom in, you could see. So you can see this is way too much. So what I would do is, and I haven't really been playing around with the sigma very much, but what you can do is you can tone it down a bit by saying, let's make that 20%. So that 0.2, it's going to take 20% of the deconvolved image and add it to 80% of the original image, so it'll soften it. And each time you want to run it, just hit the reprocess, and it'll go off and have another go. So I mean, that's still too much. I mean, that some of these other styles aren't too bad, but that one's horrible. So probably soften it a bit more, or play with the sigma. The denoise will basically just do a very basic denoise on the whole image. Again, not as good as some of the other tools in the post-processing world, but you can denoise. That's taken some of the noise out anyway. You probably can't see that on the video. And then the third option is just a very basic unsharp mask. So put an amount in, so let's say 5, choose a kernel and a sharpen sigma. Again, you're going to have something that works with the downscaling, so you will need to do some experimentation. And then each time you play with it, you can let's see, so that's that. And if I take the denoise off and the sharpen amount off, this will probably be, yeah, it's a bit softer without, so it does sharpen it up slightly. But they're very, very basic tools. You may or may not get any value out of them. So anyway, that's what they do. So thanks very much for watching. If you've got to the end, very much look forward to any feedback, and clear skies.